Today's class is going to be about good measurement and bad measurement, precision of measuring instrument, and creative project work. Today's world is driven by lots of data. So it is in science as well. We perform many measurements, and between measurement, collection of data, and analyzing data lies accuracy and precision. Assume that we want to measure 1.01 yards of a cloth. If we get 1.00 yard, then we can say 1.00 yards is closer to 1.01 yard. That means our measurement is accurate. Accuracy tells you how close your measured data to the correct or the true value. And over here, the true value or the true data is 1.01 yard. Similarly, if the true value is 1.01 yard and then you measure this data, because 1.01, 1.00, 1.03 and 0.99, they are all close to one another, we will say this data is precise. Wider apart, leading to higher levels of uncertainty when you are measuring volume. You can always estimate one extra digit beyond the precision limit with any instruments. So for example, and you always want to look below the meniscus when you're reading measurement. If we say the volume in this graduated cylinder is 22.0 mils, we can estimate it to be 22.02 mils. But what you can do is that you cannot say the volume in the graduated cylinder is 22.0256384 mils, because all these numbers are beyond the precision limit of the graduated cylinder. When you are measuring masses in the lab, you can use the top pan balance or the analytical balance. The analytical balance is more precise than the top pan balance because it has more digits. When you are measuring masses, the more digits you have on the balance, the more precise your data will be. Assuming you are taking the mass of a beaker in the lab on the top pan balance, and your value that you get is 58.9 grams. It could be that it's 58.91 or 58.94 grams, but it cannot be 58.9156.328 grams, because all these numbers are beyond the precision limit of the top pan balance. Let's check ourselves. Question 1. Which of the following statement uses exact numbers? A dozen. A dozen is exact because it contains exactly items. 12 items. Benjamin Azamati, Ghana's fastest sprinter, runs 100 meters in 9.90 seconds. When we say 9.90 seconds, that's not exact. Why? Because 9.90 seconds could be 9.901 or 9.904 seconds. If you round off 9.904, it's still going to be 9.90 seconds because there's always room for adding extra digits. Marian, Kingsley, Daniel, and Yao work as quality control chemists in a toothpaste lab in Ghana. When testing for stannous fluoride content, which the true value is 0.454% weight by volume, they found the following results. Please label each of their results as accurate and precise or inaccurate and imprecise. So if we are looking at Marian's data right now, we know that the true value is 0.454%. So we have to compare all these individual data to the true value. 0.54 is closer or is the same as this true value. 0.453, 0.449, 0.455, they are all closer to the true value. That means it is accurate. If you want to determine if this data is precise, you have to compare each individual data to one another. So 0.454 is closer to 0.453, closer to 0.449, which is also closer to 0.455. So we will say that this set of data is also precise. That means Marian's data is accurate and precise. That's good measurement. For the rest of the questions, give it a try and check your answers. Our project work for today will be to collaborate with a friend or group of friends and use art and your imagination to explain accuracy and precision to your parents or grandparents. Feel free to share your models with CocoChem at cocochem23@gmail.com. In summary, we've seen that science is driven by measurement, and accurate and precise data affect the way we analyze data. We have also seen how we can use critical thinking and problem-solving skills to solve problems. Please subscribe for more free chemistry videos.